You have heard about electric cars from the likes of Tesla with the Model S, Nissan with the Leaf, and Chevrolet with the Volt. We all know that electric cars are part of our future as a means of clean and renewable transportation. The ultimate goal is to create an electric car that is efficient, lightweight, and compact. In an electric car, there are two ways to accomplish this. Either by making a high-speed motor, like more prominent manufacturers such as Tesla, or a high-torque motor, which is where the electric hub drive wheel comes into the picture. A hub-centric electric drive wheel is a brushless DC motor integrated directly into the wheel and adjacent to the suspension arms. Comparing this to conventional combustion and electric car layout, which utilizes drivetrain components such as differentials, drive shafts, and gears, this motor vastly reduces transmission loss. Thus, mechanical efficiency and torque increases since the motor is directly bolted onto the wheel. The following design considerations were given when conceptualizing the hub-centric electric motor, namely, large starting torque, which electric motors in general share, a wide speed range, and a high energy density, in order to compensate for the large unsprung weight brought about by the motors. It is also notable that these motors have brakes attached to itself and calipers bolted onto the suspension arms. The brake system can be said to be integrated with the propulsion system through the help of regenerative braking, which recovers energy via braking to recharge the battery. This is done since the electric motors take up space originally set aside for a conventional braking system. Diving further into the comparison with conventional or more widely accepted systems, it can be seen in terms of weight perspective. A conventional two-wheel drive layout and all the accompanying drivetrain, including transmission, drive shafts, and the like, would weigh about 110 kilograms, while an existing Protean hub-centric electric motor solution would have a weight of 62 kilograms, which is about 44% weight saving, which can be used for more batteries or getting more creative with their placement throughout the chassis. For comparison, a compact car with a conventional gas design with 100 horsepower has around 123 newton meters of torque, versus a car with this in hub solution for the same horsepower would have around 650 newton meters. This design philosophy can now dictate a more passenger-focused approach, which will lead to larger cabins and possibly more emphasis on crash protection and the like. Unlike conventional designs, you can also have greater control over all four wheels, which only cars with a bulky all-wheel drive system can replicate, whereas we have a compact and lightweight alternative with a hub-centric electric motor design. The patented idea for such a design with a complete and integrated drivetrain solution that makes use of the hub-centric electric motor was filed by Delbert Tessar, who works with Protean Electric in March of 2014, and approved in September of 2014. Protean Electric was founded in 2009 and is the recipient of the World Economic Prize for Technological Pioneer in 2012. It received fresh funding of $40 million, and as of June 2018 is a strategic partner of Weifu Technologies. The reason why it is so complete is that unlike other electric motors of this type, the motor integrates the braking system, transmission with the clutch and suspension design into one unit or assembly. As stated earlier, the braking system is a friction brake incorporated into the motor, as well as suspension which has the capacity to regain power from stopping the car and use that to recharge the battery. Its main goal, however, is to create a multi-speed motor, as the current motor designs are just of the one-speed variety. Ultimately, they propose a complete way to miniaturize the drivetrain of a conventional automobile into a space designed originally for the wheel hub and brake rotor assembly. Talk about efficiency. There are so many more applications or innovations that can be done with or through this technology. However, one aspect that still needs to be ironed out is the drivetrain controller or the electric differential, which communicates how much torque and power need to go to each wheel at the particular instance in time, say in an emergency situation where the car has to suddenly stop or unexpectedly go over rough and uneven terrain. Another aspect that needs to be addressed is to lower the unsprung weight, which is the weight between the road and the suspension components, in order to give passengers and consumers a comfortable ride, which they are all accustomed to with conventional designs. However, the potential future applications are quite exciting, as we can for the first time design interiors to be like lounges or office spaces, and can be given more artistic freedom with body lines since we are no longer hampered by electromechanical components strewn throughout the car. One innovation that is hoped is that this kind of car design can be incorporated into autonomous cars, as artificial intelligence would know best on how to fully utilize and control the four independent hub-centric wheels, a design that can offer safety and convenience for everyone.